Alright, there have been a lot of developments. Hey guys, welcome back to the Zenith 16-inch porthole restoration project. There have been a lot of developments since we left off. Let me get you up to speed. First off, if you didn't see the news, hear the news. My 5 AXP4 is back in business, which is good because I really want to use it in the set rather than using the metal cone picture tube in the shock hazard. Turns out I had to remove the base, sand up and retin the leads, put the base back on, solder them all up. It looks like G2, aka the second anode, wasn't making contact, which is causing the crazy readings. Alright, back to this set. Okay, service info. I had shown you guys a copy of what I found in Riders, which is right here, which is okay, but I went and ordered up a copy of the Sam's directly from Sam's Photo Effect. They are still in business, 15 bucks, instant download. So I got the PDF version of that and their schematic. I wanted the Sam's because it has a parts locator, a photo of the bottom of the chassis with call-outs to all the parts and a parts list. Because the next thing I did immediately was order up replacements for all the power resistors. All 1, 2, 3, 4, 5, 6, 7, I believe there are. These guys have to go. They're crusty, they're falling apart. In total, no taxes, no shipping, just the parts, 25 bucks. High quality power resistors are not cheap, but it's well worth it. This is a really well built set. I want to get it running very reliably, especially this guy. 25 watt chassis mount, enameled power resistor. That was about $850 just for that one part. Alright, caps. I have been blowing through replacing the Bumblebee caps. This chassis, as I mentioned earlier, is very easy to work on. It's very well built, but also very easy to work on, so I've been going through and doing all that. But I found some odd parts along the way, which I also wanted to consult the service info to verify, and that would be the giant domino type mica caps, which I don't think are really mica, and these guys. There's a closer look at one of them. They are 0.1 microfarad 600 volt caps. There's one down here, and these two are in parallel up here. Let's start with these guys. I took one of them out. So, mica mold. We have green, black, and orange, which I surmised, and still surmise, means it's 50,000 picofarad or 0.05 microfarad. Now it's going to a 6AC7, or was, till I clipped it out. Right here, which I think it's a second video amp. On the schematics, though, they show a 0.047. And they show on the other end of it coax, I'll show you in a bit, going to the contrast control, which harkens back to the Westinghouse I worked on, where to vary the contrast, which generally equates to gain on the final video amp, instead of changing the bias or the gain of the tube, they treat it like a volume control, and they have that one leg of the pot going to the signal, the center wiper going to that tube, and the other side going to ground. And then they have coax, because it's going from the front back to here. Not a good thing to do, but this doesn't have coax. It's just one of these blue wires in this bundle, which seems like a really bad idea to have like 5 megahertz video signal just going through unshielded cable. So I'm still trying to figure that out. If I measure this, it's closer to 0.1, which I think is what happens when caps are leaky. I think they go up in value. So I'm still analyzing this one. This one, however, brown, black, red, 1 0, 2 more zeros, 1000 picofarad. That is what the schematic calls for exactly in this location with those connections. So I think these two are definitely paper caps. I say think indefinitely. I'm leaning towards these being paper caps inside a Bakelite housing, and I think this is a 0.05 rather than 0.047. Why did they use these? I think they thought they were more stable. Reality is they're not. If anything, they're worse. Alright, so let's move on to these. These are used in horizontal circuitry, like off the damper tube, part of the flyback circuit. So they they get hammered with some pulses. You want to use high quality, high reliability caps for these. These might be oil impregnated. They're in a type of ceramic, very hard plasticky type of cap. They remind me of Duramold caps. Curious thing about these is none of these parts have a manufacturer's name on them. Some of these say Zenith, the rest nothing. I'm used to seeing Aerovax, Cornell, Dublier, Mallory, something like that. They might order these directly from a manufacturer. Maybe they made them themselves, or they own any subsidiary that made them, but none of these parts. So I don't know what kind of cap this is. The parts list doesn't say. Just that it's just 0.1 600. So what I suggest you use for caps like this, caps in critical circuits, are caps like these. Rather than these, which are metallized polyester film, use polypropylene, ideally foil or polypropylene film, metallized film. Foil means it's actually a piece of like aluminum foil and a sheet of plastic wound together. Metallized meaning the metal is vacuum deposited. You can argue back and forth which is more reliable, which is more stable. I've seen both, but regardless, Orange Drop 715 or 716P are really, really good caps. So that's what I'm going to use. And why do they use two in parallel here? They needed 0.2 microfarad, I guess, and maybe they couldn't get them, or they between the two of them, I thought it'd be more reliable. Polypropylene has a better dissipation factor. It's more temperature stable. But the trade-off is dielectric constant is lower, I guess it would be, so you need a lot more volume to get the same capacitance. This is a 0.1 630 volt cap polyester film, so it's basically the same specs as this orange guy, but obviously a lot smaller. Alright, I've identified a few more of the parts on the chassis. Check these out. Zenith did everything their own way. These are the IF transformers inside these oddly shaped tubes. There are slugs you can adjust from the other side. That, I believe, is the ratio detector sound coil with some ceramic tubular caps mounted around it. Definitely do not want to mess with anything below this line, anything in this area, if I don't have to. At first I thought those were the horizontal coils, but no, they're behind this cardboard. The horizontal oscillator, or the phase coil, they're up here, so you can adjust them from the front. Normally they'd be at the back of the chassis somewhere. I hope they don't need to get adjusted very often. Likewise, the width coil is up front too. So the horizontal coils are all right up front rather than being in the back. Okay, back to service info. So although I have the riders, which is a reprint of the Zenith info, I've got the SAMs. They're still kind of small schematics, and the SAM's quality isn't that great. I've already sent them a note asking if they can rescan with a higher quality, and in the past they have. So I'm hoping they will for me again. But then I remembered, hey, I've got the Wallace Telliade, which covers 47 to 53, so it's got to be in here, right? Now, the neat thing about this is they list not only all the model numbers, but the names. See, all these early Zeniths had nicknames. So we have a G2952R. That is the St Regis model. So that is the name of this TV we're working on, the St Regis. 29G20 at pages 17 to 19. That's actually not quite right, as I've already discovered because I looked ahead. Because the tube and trimmer layout, 29G20, so it's actually on page 16. And then the schematic, and I didn't read this carefully at first, is there are two versions of the schematic. Now, this is one version, but that's what I started looking at, but that's not what I have. I have this version. And they say you can identify it. Zenith television receiver chassis, 29G20 with S15 940 turret tuner. This chassis identified by a 6BJ6 RF amplifier and a 3/4 inch blue disc stamped on the turret. Yeah, I do have a 6BJ6 tube. The older version has a 6AG5 tube. So this is the schematic that matches what I have, I hope. I'm taking a break from the recap action to test some of these caps I've been clipping at. In particular, I want to check these guys. So I already talked about that, but I found a couple other that I highly suspect are actually paper. 0.01, another mica mold, and this is also mica mold, even more mica looking, but it's 1,000 picofarad, which is kind of on the fringe of being paper versus mica, so it could be mica. Let's start out with this big guy, which I think should be a 0.05. And, well, right away the eye opened when I'm in the short position, so that's not a good sign. And if we check for leakage, it's okay at 100 volts, 200 leakage. Alright, so yeah, that's not a good cap, and I can't check for value because it's showing it as a shorted cap, so yeah, that's not good. Let's check the 0.01, allegedly. Mica cap, maybe. Also showing short right away. And it's leaky at only 100 volts. Alright, that's crap. That's going to be paper inside there. How about this 1,000? No, it could still be bad and be mica. We won't really know for sure until we, unless we busted it open. Let's see, this might actually be okay. Let's check. Alright, so it's not leaky. What about the capacitance? Okay, it's not showing short when I'm testing for capacitance. And let's see, C3 range. Yeah, that's actually tests good, so I could have left that in. I already took it out, so that's I could tack it back in. But the other thing about these is the leads on these are super heavy, and to unsolder them to test it, you risk fracturing the seal along here. You're even just twisting them so you can read the dots. So it's kind of a pain to deal with. But yeah, okay, I'll replace that with a mica cap. All right, learned something there. And how about this big guy, 0.1600 in this special material. Let's connect 0, and it should be good for all the way up to. Oh yeah, well, yeah, no, that's leaky at 300. That's crazy leaky at 500. And as far as capacitance goes, yeah, it's showing a short. Let's see, the C2 range, a little high. It's showing more like 0.15, but the eye is mushy. That should be a really distinct pie wedge, but when you rock it, it's really fuzzy, and that means leaky. So, nope, sorry. You are no good. Alright, what else we got? Oh, we can check a good old-fashioned Bumblebee. Should be a 0.047, good to 600. What? Bad at 2. This is why I shotgun recap, by the way. I don't need caps popping and smoking if I tried to power this up. No, not all of them would fail because it probably doesn't have 600 volts on it, but just why even bother? Just be careful and keep track of your work as you go. Yeah, sort of same deal. You can kind of measure the value. It's in the ballpark of 0.05, but it's really fuzzy, which means it's leaky. Oh, we can do another one of these guys. 0.047, 600. So it's curious. Same deal. Same capacitance, same voltage rating. 2 different package styles. And all indications are that they're both original. Like the joints didn't look reworked or anything. Better, but it's still leaky. Just not as leaky as the Bumblebee. And can we measure capacitance? just barely a wedge, barely. So, yep, these are all bad, not wasted effort. Yeah, that's enough. So, yeah, judgment call on these. It's hard to tell. There's so many different color coding schemes. Some charts I've seen say if it'll be a white or a silver dot in the corner if it's paper inside. These don't have that. I'm just going by experience, knowledge passed on from other restorers, and just knowing how the materials are used, that you don't get mica caps in that large a value. But same company, different packaging style. Still stick with that advice. If it's above 1,000 picofarad, it's probably paper. If it's 1,000, 2,000, 4,700, 3,300, could be either one. Let's switch to looking at the power supply for a bit. Just pulled the chassis out. It's on these pretty serious shock mounts. I guess to isolate hum or vibration from getting through the system. I don't know. just these two bolts held this down. And I had the one ridiculous repair we saw when I first looked at this set. At first I thought this was just piggybacked onto this cap to replace a bad section in that, but no, there was actually another cap down here at some point that they just busted off, taped this one to this one, and wired it up down below. There's not a whole lot to this. There's a 10 ohm resistor down there, that's it. I presume that's a filter choke. One on top side too. And that, it's rather huge, but really it's just the filament supply for these two tubes and then B plus for the set. And that is a filament transformer for the rest of the tubes. Then again, with all those power resistors up there and the dual 5U4s, they must be quite a bit of current on that B plus rail. Alright, so what am I going to do? Well, obviously, undo this mess and replace these caps. Both of these are on phenolic bases, so I'll use adaptive caps for those. That's a twist lock, so I'll have to think about that a bit. Nice touch, heat shield between the tube and caps. They knew that heat was not good for capacitors, so that's why that's there. Let's just get this guy out of here. Good riddance. Just a single cap. 40 microfarad, 500 volts. You can see an obvious date on it. Anyways, that should be pretty straightforward. What I'm hoping to do is actually try powering this set up pretty soon. My Mauser order got delayed by a day, thanks UPS, so Resistor should have been here today, but they'll be here tomorrow, and at which point I'll pop them in. I pretty much replaced all the paper caps, including those guys up there. Those two are electrolytics. Those are specialized ones for the horizontal and vertical centering. One of them is actually, I think, 500 microfarad, but only 6 volts. But we'll replace them eventually. A few others like these. There's one buried way down there. But that's going to the phone vision socket. Zenith had an early subscription system where you'd plug your TV into the phone line and it would descramble the sync pulses so you could do pay-per-view movies. We're not going to be using that, so some of these caps, once I realized what they were used for, don't really need to get replaced. Otherwise, I think, there's another little electrolytic there. I think all the paper caps have been taken care of. So it leaves there's actually 4 electrolytics up here. There's 1, 2, 3, and then there's a smaller one up here. Sorry, up there. And we got them down here. So geez, altogether there's 7 can electrolytics in this guy. So I want to at least get these guys replaced before I think about attempting a power up. It's getting kind of late on Friday, and I was turning on my power resistors. Now, I've been using Mauser for years, and I usually use FedEx, but they keep defaulting to UPS for the last couple deliveries I've gotten. I used UPS, and it was all right. This time, not so much. Come on, guys. Let's go. Meanwhile, I've been working on the power supply. I took out the cap next to the one that had been removed, and yeah, this is why you can't always do a reformation or controlled power up. This has already lost its guts, so I just popped those 2 guys out. I still need to drill the rivets out, and I cleaned this up a bit. Typically I use CLR, but in this case it was kind of sticky, quite possibly from these caps venting, so I used denatured alcohol. And you see the plating is gone or discolored in a lot of areas, but originally it was all kind of shiny like that. So, remove this cap, populate these. It looks like all 3 of the 4 sections of this were just shorted together. Well, maybe this is a replacement too. I gotta see what the original values are. So it was just 4 identical caps. That's typically what you'd find in a replacement cap, kind of universal replacement. I suspect the original was a little different. So yeah, it looks like on the original there was a 100 microfarad cap. Don't know the voltage, but I'm going to guess maybe 450. So maybe they combined a bunch of sections on that. So we got C1 15 microfarad, C2 40 microfarad, C3 20, and then C4 100. That is 4 different caps. We've only got 3 on this chassis, so that doesn't quite make sense unless some of these are, usually they would say like C1A, C1B or something like that. Alright, I gotta do a little bit of research. Then again, the fact that these have symbols next to them, a half moon and a triangle, that's got to be the multi-section. So I'm thinking C1 and C2 are just single caps, and C3 and C4 is the multi-section, and the original's gone, and they tied 3 of the 20s together to try to make 100, which of course it doesn't. I think that's what's going on there. We shall find out all in good time. They must have heard me complaining 10 minutes after I filmed that last segment. My power resistor showed up. Also heard back from Sam's PhotoFact last night. They did rescan the PhotoFact. It's much, much higher quality, very legible. And here they are. We have 6 silicone coated, made by Dale, and 1 vitreous enamel by Omite, old school. So this will be the chassis mount one where we use the original hardware, and these guys replace all the crummy old sand coated resistors. Well, after reviewing the service info carefully, it turns out that these 2 caps were just single section caps, and the replacements both have been replaced and with a much larger value than they should have been. This really, well, I carefully reviewed the service info and determined that these 2 were just single section capacitors. the replacements were not appropriate. This originally was a 15 microfarad 250 volt cap. That's it. And this is a 40 microfarad, I think 300 volt cap. So they had a 40 in here, and this they tied 3 20 suctions together to make a 60. These come right after the rectifier tube, and you don't want to put too much capacitance on it, or you strain the tube. And this is the guy that's 100 microfarad and 20 microfarad dual suction cap. Then we have 2 filter chokes, one above and one down below. So more filter chokes, less need for capacitance, plus of course we have all the electrolytics on the main chassis. And look how honking this power transformer is. It still seems crazy to me. And believe it or not, there is a tabletop version of this set, which is essentially the same chassis. I would rate it as the heaviest tabletop set I have ever tried to pick up, because it has the transformer this big, and it has that. They stick this inside. They take basically this chassis and stick it above this one in kind of the back corner. And aside from that, it's a very heavy wood cabinet. And it's just a 10-inch set, but it's got to weigh way over 100 pounds. At any rate, that's all I had to do is just do dinky caps here, and then I got to pop this guy out and just 2 caps on that. All the new power resistors have been installed, and you know what? Every single one of the originals was open, so had to do it. So there are a few paper caps left. There are a couple of oddball .0012 bypass caps used in the audio circuit. There's a .0047, a couple of them up here again in the audio. There's one that's a nightmare to get at inside here, because it's behind this cardboard cover, which is held on by screws on either side. So we like take this whole thing apart, and that is part of the horizontal width, linearity, frequency conglomeration there. And these caps are the bypass caps for the horizontal and vertical centering or electrolytics. Very low voltage, like 6 volt caps. So I am inclined to leave all those in place because they're hard to get at, or I don't have the right values, and I think they can handle it. They're not like the major power supply components. So I'm going to flip this back down. There's a bit of work to do with top side. Still some areas are filthy. I need to verify we got the right tubes and the various sockets and whatnot. And just a little bit of work to do on the power supply. Then I might try powering this up. At first, with the rectifiers out, I'm going to make sure that we got the power going through everything and all the tube filaments light up. And then we do a full power up. And I also got to rig up my test CRT. I'm not going to put in the 16 EP4 metal cone picture tube. Not at this stage of the game.